Hello, in this video we're going to see how to create a slab from a Grasshopper style. Basically a slab that is using a Grasshopper definition in the background. In this example we will just create a slab that has a hatch pattern on top of it. Of course we can achieve the same result by drawing a slab and drawing a separate hatch by drawing the boundary curve. But having both entities in one single object makes it easier, for example, to change the boundary through control points, or if we need to subtract the boundary inside the slab, for example, we draw this rectangle and we run the slab subtract boundary command, the boundary will perform on both objects, the slab and the hatch. Also, we can use this slab style in a new roof style, and therefore have roofs that already integrate hatch patterns in their slopes. And again, if I modify the boundary of this roof through control points, the hatch pattern will update. Also from the top view, I will get a nice representation of the roof or the slab textures. But let's start from the beginning. I am in a new file. I'm going to open Grasshopper, and we'll generate this Grasshopper definition that this style was using. First of all, I need to create a surface that will be the input geometry for the new slab. I will generate a surface with an opening in it. I will just trim this inner part. And now I'm going to reference this surface in Grasshopper. Slabs can get curves and surfaces as input geometry, but the reason to select the surface is that this will be the only option to figure out about inner boundaries in order that the slab subtract command works properly fine with this new style created from a Grasshopper definition. Now, the first thing we can do is to extrude the surface. So this will be the base. I'll create a new parameter for the thickness. I can call this thickness. Define the direction, which will be the Z vector. And now I want that surface is the top face of the slab, so we'll need to extrude this downwards. I will need to use here a negative value. Now, in order to create the hatch, I will need to use a specific component provided by VisualARQ. It's true that Rhino has its own hatch components, but unfortunately these are not compatible with VisualARQ Grasshopper styles right now. They will be in future versions, but up to now we will need to use the VisualARQ hatch component that we can find under the VisualARQ components. Now we need to extract the curves from this surface. I will explode this surface with the brep deconstruct component. I have a list of edges that I need to convert into closed curves, so we'll need the join command for this. So now as a result, I've got two polyline curves I can plug directly into the boundaries. Now, if I want to control also the options for this hatch, such as the pattern, the rotation, or the scale, I need to use a hatch options component. First of all, I will use a text component for defining the name of the pattern, and I need to use the one that is under params primitive text. And if I do right click, I will be able to set one text. And this needs to be the same name of the hatch patterns that I have loaded in my document. I will use the single one as a default. Now I will put here 2 more numeric sliders for controlling the rotation. I will edit this and rename it as rotation, pattern rotation. And if I edit it, I will set this that goes from 0 to 360. And I will change this rotation input and set it to degrees and 0 as a default number. I will copy and paste this to connect it to the scale. I will rename this as a scale, edit it, and this will go from 0 to 1000, for example. If I check this error message, I can see that parameter scale must have a positive value. So we'll set this to 1. Another thing I can do is to group these inputs in order to give it a name. And now these parameters will be displayed grouped inside categories in the VisualARQ properties and style dialogs. Now, in order that VisualARQ identifies these components as parts of the final style, we need to connect these to geometry components that are not further connected to anything else. So in the case of the slab, I will use a geometry param. I could use also vrep, but this is more generic and will work with any geometry that we plug in. And I will rename this as a slab, so VisualARQ identifies this object more easily. In the case of the hatch, I need to connect this to a hatch param. I can find it under geometry, hatch. Just notice that we have another hatch component here. Beware that this is the one belonging to Rhino and doesn't work with VisualARQ Grasshopper styles. So at this moment we will use this one. If you do right click, you can change the name, but I will leave it as hatch. Now we can save this definition. Let's call it slab with hatch. I can close Grasshopper. And now we can create this new slab style. So I'm gonna open the slab styles dialog, right click here, go to new, select Grasshopper slab style, and then we'll need just to follow the steps of this Grasshopper style wizard. I will select this Grasshopper definition. Next, need to define the style name, the definition units, and which is the linked property that acts as the slab boundary, in this case, the surface. Click Next. I can select now which components will be displayed in model view, in plan view representation, or just in preview, which will be the geometry visible when we are inserting this object or when we move it after the object has been inserted. I recommend you that in complex definitions, you just enable the components that are necessary to see the object while you insert it, so the performance will be much better. Okay, we click Next. We can see here all the parameters in the Grasshopper definition and how we want to edit them. We can edit them by style, by object, or by definition, meaning that this parameter will be hidden in VisualARQ dialogs. Actually, in all cases, we want to edit these parameters by object. Also, we can display them by groups. So if we select the pattern group, the one that we created in Grasshopper, we only see those parameters inside that group. And here we can also change the default values. Okay, we click Finish. The new style has been created. If we expand it, now we can select any of these components and change, for example, the display color. I will choose a gray color here, or the print color. I will choose the same gray, and so on. Click OK, and now we are ready to insert that new slab. I select here the slab with hatch style and insert it into the drawing. You can select it, go to its properties, and now we'll be able to change the thickness, to change the scale, or change the pattern name. For example, I can call this grid. I will change the scale again in this case. Now, if we want to use this slab in a new roof style, I'm gonna create a copy of this style to use it on a new roof. So I will select this one, do right click, duplicate, and I will call this slab for roof. Now, in order to figure out the name of the hatch patterns, I will just accept the changes here and go to the document properties. We can go to hatch and figure out here all the names of the hatch patterns available. In this case, I will use this roof tiles pattern for the new slab style that later on I will use on the new roof style. Now, I go to the roof styles dialog, create a new roof style. I can call this roof with hatch. And here under slopes, I will select that roof slab for roof slab style. I click OK, and now I can insert that new roof style. I can see that the scale and the direction of the pattern is not the one expected, but I just need to modify in the original slab style. Slab for roof. I will rotate this 180 degrees and change the pattern scale to 0.1. Maybe I will assign a smaller value. That's it. Thanks for watching.